Hello, this will be a very quick introduction to Cartesian space, to points on Cartesian space, lines as relations of points, and tying in the visual and the algebraic representation of those relations. First of all, you'll notice that we have a y-axis, that's the vertical axis, and an x-axis, which is the horizontal axis. That is the standard normal way of representing Cartesian space. Next, you'll notice along the top here we can do various things. What I'm going to do right now is I'm just going to orient this into the center. So I'm using this as a mover. Now I'm going to plot a point. And I'm just going to throw the point right here. So what you'll notice is that the A is 1 along the x-axis and 4 along the y-axis. I could also plot another point by simply using the coordinate system. And this one I'll do as -2 and 3. There we go. Here's another point. That point is going to be called B. And I'll just right-click and delete it. We don't need it right now. So there's two ways of kind of laying out points in GeoGebra. Now I can take this and I can move it along. And as I move it along, take a note of the top left of the screen because the coordinates change. So here both are positive. Here the x is positive. I'm positive at x and negative in y. So 5, -3. Here I'll go to -5, -3. So I'm negative in x and I'm negative in y. And here, let's keep the same system going, same numbers. I'm negative in x and positive in y. And here I'm at 0, 0. That's the center of the coordinate system, which allows us to do a lot of amazing things. So, but we're not going to worry about that. We're just figuring out how this system works right now. So if I take another point, well, let's just, I'll plot a line, but I'll do it with another point. So I'll just put another point here, and now we have a line that joins AB. I'm going to change the way the algebraic, so we have a standardized equation. I'm going to change it to y = mx plus b, which is the one I want you to get familiar with. And I will give it a nice slope, so that's right. So right now this line has slope 1. So if I tighten this up here, I go across one step here, one step up, one step here, one step up. So rise over run is the measure of the slope. And so that's y = mx plus b. That's the line there. Now we're going to keep the same slope. We're going to change where it crosses the y-axis. So now you'll see that it's x plus 3, roughly, x plus 2, get it exact, x plus 1, x minus 1, x minus 2, x minus 3, and so on. So I can manipulate the line in GeoGebra that way and just show how that the equation, the algebraic expression of it changes. I can also grab one of the points, B, and I can shift things around A. So let's put A on. Okay, so we have the same y-intercept. So you'll see the plus 3 stays the same, and the slope, here the slope is 0 or close to 0. So we have no x, we just have y = 3, and here the slope gets larger, 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 larger. 25. We can get even larger and larger, and then at this point it's a vertical line. We have x equals 0 because we have a vertical line. We have no slope. So x equals 7, x equals 10. Okay. And then the same thing. You see the y-intercept changes, and now the slope is negative and goes towards negative 0. Now it's back to being positive, close to 0, and then gets steeper and steeper. It kind of makes sense. The steeper it is, the higher the slope, the higher the value of m. Now, how can I demonstrate to you that this is a relation? So one way I can do that is by getting another point here, and I'm going to put that point on the line. And what I'm going to do, the line will stay the same, but I'm just moving the point. And I'll zoom out. So that line, remember that line goes forever and ever. And these are all points that are on the line. So it's a relation between a set of points. And there's a gazillion of them. There's an infinite number of points as the line keeps going and going and going. Now, what happens if we add another line? So I'm going to add another line. Y equals the same format, 6x minus 9. So now I've added another line, line. We have line F, and we have line G. So this line here. It has a different slope. So here the slope is 0.27. And you can change it to something a little nicer. Let's change it to slope of 1. And here we have a slope of 6. So you can see line G is steeper than line F. Okay, so line G is orange. And line G is going to stay fixed because I mapped it with the equation, so it's going to stay put. And this line is going to change. Well, we have a point of intersection here. If we zoom in, there's a point of intersection right there. And I can find that point in various ways. In the booklets that you have an algebraic solution for that, but here we can get a nice visual one by zooming in, dropping a point down, and point C now is the intersection of line F and line G, and it's at 2.6, 6.6. This has been a short introduction to GeoGebra and the Cartesian coordinate system. Thanks for watching.